Hello everyone and welcome back. It's Miss Peltier for our 23rd lesson for COVID-19 on properties of logarithms. Our lesson for this will be due on May the 15th. So make sure you check with your teachers. If you have questions, join our Hangouts, send messages through Google Classroom, or email us if there's anything that we can do to help. For our properties, so we're still going to be solving. We did some solving the last session and the session before that. And so we're just kind of adding a little bit more to the types of questions that we may have or equations to be able to solve. So we have two properties. Our first property is our product property, and these are, notice it does tell us that properties of logarithms, properties of exponents can be used to develop the following properties of logarithms. So basically our logarithm equation properties came from exponents, because remember, a log is simply an inverse of an exponent. So notice if we have log base x of a times b, that could be, as we like to say, expanded or separated into log base x of a plus log base x of b. Notice the logs have the same base, and all we've done is taken that product and separated it into two separate. It still goes back the same direction, that if you have them separate, you could put them together as multiplication, because we know that multiplying with exponents is the same as adding the exponents if you're multiplying and your bases are the same, as well as quotient. Notice the difference. When you're dividing with exponents, you subtract the exponent. So notice how that works for our logs as well. When you have division, it becomes minus. A couple other things I want to point out to you, that remember, they tell us our numbers a, b, and x should all be positive numbers, and x cannot be equal to 1, meaning our base cannot be equal to 1, and a and b, no matter where your a or b is in your equations, has to be a positive number. Okay, so let's use some of these properties to be able to solve some of our equations. Notice it does say check, because remember, just like we did on the last session, when we got an answer, we wanted to make sure that we were following that a, b, and x are positive, and not that x is not equal to 1. Okay, so what I notice first is when I look at my equation, I have a log base 5 and a log base 5 with a plus in between them. So if I could put those two together, I would have a log equal to a log, and that's the exact same kind of problems we worked yesterday. So if I put these together, I can use my property from above, my product property, and write it as 1 log base 5, and I'm going to take this a and this b, and I will be multiplying those together, if you will, and equals my log base 5 of 24. Almost wrote 25. 24. So now I have a log equal to a log. If I were to multiply these together, that would give me log base 5 of 8x equals log base 5 of 24. Now it's just like we did the other day. 8x must be equal to 24. So when I divide, x would be 3. Okay, so same, very similar over here. It looks a little bit bigger because there's more letters all over the place and things, but still, I know, first thing I see is that I have a log base 6 and a log base 6, and I'm subtracting them. So when that happens and it's subtraction, we know we're going to be using our quotient rule, because with exponents, subtraction means divide. So we're going to write it as one single log base 6, and I'm going to take the a part and the b part and make it into a fraction. So 2x divided by 3. And it's always the first divided by the second, equals log base 6 of x minus 1. So once I have log base 6 and log base 6, I know their stuff must be equal to each other. So I can write that as an equation. 2x divided by 3 is equal to x minus 1. I could get my 3 out of my denominator, multiply both sides by 3. I'm going to multiply this whole side by 3. So that would, here they cancel. That gives me 2x equals 3x minus 3. When I subtract my 3x over, I get negative x is equal to negative 3. So then divide by my negative, and x must be 3. And notice we need to double check here. If I plugged a 3 in, 3 times 2 is 6. That's positive. I'm good. 3 minus 1 is 2. That's good as well. Okay. So our next two examples, very similar to those. We have a minus. So we're going to do the same thing. When I look at these, my logs all have the same base. When I see that minus, I know I'm going to be dividing my 4 by my x plus 3. So we will write 1 log base 2 of 4 divided by x plus 3 equals a log base 2 of 8. Once my logs are on both sides, I know I can set their stuff equal to each other. So my 4 over my x plus 3 is equal to 8. And I'm going to write the 8 over 1, so then I see I have a fraction equal to a fraction, and we can cross multiply. So 4 times 1 gives me 4. And when I multiply 8 here, remember you have to FOIL or distribute. So make sure that you distribute your 8 times x and your 8 times your 3, which is 24. So now when I solve, I subtract my 24 over, and I get negative 20 is equal to 8x. When I divide by my 8, I get negative 20 divided by 8, which can be reduced. 4 goes into both of those. 4 goes into 20 5 times, and 4 goes into 8 2 times, so negative 5 over 2. Double check, if I were to plug a negative 5 over 2 in here for my x, it's this whole value, my x plus 3, that must be greater than, that must be a positive value. So if I plug in a negative 5 over 2 plus 3, negative 5 over 2 is the same as, 2.5? So if I take 2.5 from 3, I'm going to be left with 1/2, which is a positive number. So that's a good value. So we will keep that. Even though it's negative, it's okay, because when I plug it in, I still have a positive number. All right, very similar on this one, but notice we've got more variables in there as well. I have a minus, so I know it's division. So when I write my first log base 5, my division is going to be my x plus 3 divided by my 2x minus 1 equals 2. But notice this time it's not equal to a log on the right, so even though we still did this, we can still do that little circle thing that we did earlier. So we're going to take our base 5, raise it to this power 2, and it's going to be equal to all that stuff in there, which would be x plus 3 over 2x minus 1, which we know 5 to the 2nd is 25. I can write it over 1 if you like to see those equivalent fractions to be able to cross multiply. And now when I do my cross multiplying, 1 times x plus 3 is just x plus 3. 25 times 2 gives me 50x. 25 times negative 1 is a negative 25. So when I move my 50 over, that gives me a negative 49x. If I move my 3 over and subtract 3, that gives me a negative 28. So then when I divide by my negative 49, it will become positive. And what goes into both 49 and 28? Well, 7 does. 7 goes into 8 4 times, 7 goes into 49 7 times. We want to double check. 7/4 is a small number, so 7/4 plus 3, that's still going to be a positive, so I know it's good there. 7/4 times 2, 4/7 times 2, that's going to give me 8/7. And then if I subtract 1, which would be 7/7, 8/7 minus 7/7 gives me 1/7, which is positive, and that's a good number. So then we know that we're confident we can keep that as a value. Okay, so those are the first two properties. We do have another property that we're going to go on for the next lesson. So make sure that you're staying on top of your work and getting that taken care of and turned in. If you have questions, jump on our Hangouts or send us an email or a message through Google Classroom so that your teachers can get to you as soon as possible to make sure that you're on top of your work. Okay, it's getting close to the end, so good luck. Y'all take care and stay safe. Talk to you later. Bye-bye.